Okay, so welcome back after the break. So we have seen some introduction, basic introduction to what are the mobile robots, what kind of the locomotions we can have for different types of the mobile robots depending on the application. So locomotion can be a wheeled or can be legged or can be a tracked. But in this class, we are mostly concerned in the wheeled robots, um, not on the legged robots. So wheeled robots can wheeled locomotion can come in different forms and different uh, you can see configurations. So one most common, which is the most common, is this differential drive type of the robots. So this kind of the locomotion is configuration of the wheels is most common. And second type of the all of us are familiar with the car like configuration of the wheels. So there is a difference between the differential drive and car like. We will study each of both of them separately later. And one other type of the skid steer and synchronous. So they are not very common in the design of the mobile robots, and we are not going to study them. So this mobile robot you see on the left is called Robot-03, and this is available in our robotics lab in 271 room. So some of you may choose this to for their final project. This mobile robot, which uses robot operating system as its software, and you can do your project based on this Robot-03 mobile robot. So let's see some real world applications of mobile robots. They are very common nowadays, especially the autonomous mobile robots. So they are gaining application day by day in more of the more and more um, scenarios. For example, the delivery robots in hospitals and homes and hotels, room service robots, and in the mines and hard to reach environments, cleaning robots, and there are a lot of applications. So some are actually being used in real world applications, and some are still under research. And one of the big application is in the warehouses like Amazon warehouse. So mobile robots are used to do the pick and place on the warehouse or on factory floor with inbuilt manipulators as well. So this we have discussed already, that different types of locomotion of mobile robots. So let's talk about the type of the mobile robots based on the wheel design. So the common type of the wheels, we know that just a wheel with axle on the both sides. This type of the wheel we have with the axle in center, and then this wheel can be the tire can be a rubber or can be the metal or can be a wood, and then this type of the wheel we are already familiar. But there are some other type of the wheels we will discuss today, which are used in the design of the mobile robots. So first see this terminologies: non-holonomic and holonomic. So non-holonomic means that the robots which cannot move sideways. For example, your car, you cannot move your car instantly to left and right. To move it from to left or right, you have to move it to steer it in some curve, and then you can move it towards left or right, right. So this kind of the constrained wheel design is called the non holonomic. But holonomic design means that you can move your robot left and right, forward, backward, and maybe sometimes sideways, right, and in any direction. So this kind of the wheel design or maybe wheel configuration is called the holonomic robots. So differential drive is the type of the non-holonomic robot, because you cannot move uh, with the like this common type of the wheels, you cannot move left and right. Similarly, like your car and like your differential drive robot, which you see in your labs, Arduino car, so that we cannot move instantly on left to left and right. So this is an example of the non-holonomic mobile robots. So let's see the differential drive robot first. So differential drive robot is the most common robot um, which are used in the domain of the mobile robots. So what is that? So differential, what do you mean you have differential drive? Meaning that we have two wheels, left wheel and right wheel, okay, and these wheels are attached to some motor, left motor, right motor, ML, MR, for example, right, and these motors can drive these two wheels independently. They are not attached with the axle, right? They are not attached with the axle. So these wheels can be controlled independently. You can remove this right wheel, left and left, I mean clockwise, anti-clockwise, slow, fast, whatever you want. Similarly, you can control the speed and direction of your left wheel, and depending on the speed and direction of your two wheels, uh, your your full mobile robot, your chassis, your base mobile robot will move in the environment. So this kind of the mobile boards, they can come in the like in this configuration, like two wheels or with a cluster wheel, a rolling wheel, a free wheel with no motor. This is exactly similar to your, actually not similar. So some students have used this kind of the mobile boards, Arduino kits with two wheels and one free wheel, and some may have used this kind of the uh, Arduino kits that we have to four wheels. Most of them use like this, and then these wheels are actually you control this two wheels as is one wheel, you control these two wheels as one wheel, and then you put some motor driver over here and some controller, uh, microboard microcontroller over here, and then you control this wheel. So these two wheels actually work as a single wheel, right, and these two wheels also work as a single wheel. So again, it is a two wheel differential drive robot. So this kind of robot you have worked in your lab already. So so you might know in your lab practice that you can move your robot forward, backward, turn left, turn right, depending on the speed of your motor. If for example ML is equal to MR, both motors have the same speed and both are moving in forward plus direction, so your robot will move forward. Okay, so there is no doubt in this. So if you turn the speed of and turn the direction of your motors, both motors minus, let's say minus MR minus ML. Here you have the plus MR, positive direction, forward direction, plus MR. So in this case, if you turn the direction of your motors backward, so it will move backward, right? So similarly, if you want to rotate your robot, uh, turn left, so you increase the speed of your right motor, this will be increased and this will be decreased. So MR will be greater than ML, your robot will turn leftwards. Similarly, if you want to move it turn right, you increase the speed of your left motor will be higher with higher speed as compared to the right motor, and robot will move leftward, rightwards. Similarly, if you want to rotate turn in place means that just you want to rotate your robot on place like this, or maybe like this, clockwise, anti-clockwise. So what you do, you just keep your speed same, like mr is equal to ml, but one motor is rotating in positive direction, and one is rotating in the negative direction. So in this case, you can achieve the turn in place, spinning of your robot. So this is a very simple algorithm, and you already have implemented in your uh, midterm projects and before midterm projects in the labs, how we can control the speed and direction of your motors, two motors of differential drive robot, and you can achieve any type of this kind of motion, forward motion, backward, left, turn right, turn on place, left clockwise, anti-clockwise. So just controlling the speed of these two motors. So this kind of design is very simple and very convenient and very cheap. The second type of the non-holonomic robots which we are more familiar is the car-like robot. Okay. So in car-like robot, like we have four wheels in car type robots, but what is the difference? That the rear wheels are connected through an axle, and front wheel are also connected through an axle. They are not independently driven, right? So the then your power is on the rear wheel, right? Then you provide the power, and it will move your robots. Sorry, move your wheels. It will turn your wheels at the same speed, right? And here you have the steering mechanism. This steering mechanism will give you the direction, right? So this will give you the forward motion. The rear wheels will give you the forward motion, and the front wheel will give you the turning motion, steering, right? So you cannot do the turn in place motion, turn in place. You cannot achieve this turn in place motion, but you can turn leftwards, rightwards, forward, backward in the car like robots. But you cannot move like this. You cannot move like this. You cannot move like this. Similarly, in the differential drive robots, you cannot move left and right instantly. So it means that is non-holonomic robots, but you can achieve this motion: forward, backward, turn, leftward, rightward, turn, um, this kind of motion. So let's say talk about the second type of the mobile robots, which are the called the holonomic robots, and they are also called the omnidirectional robots, because they can achieve the direction in any they can achieve the motion in any direction. How they do it? So they do it like with the design of the special type of the wheels. For example, this type of the wheel. So what is the wheel? So this is the wheel. On top of the wheel, they attach rollers. They attach rollers like this. Okay. So this roller will be in contact with the ground, right? There can be one roller, maybe more than one, two rollers or three rollers, like this. So these rollers will be I mean they are free to move, free to rotate about this axis, about this, they can rotate about this axis like this, and then wheel can move forward and backward also. So it means that this single wheel, they can achieve the two type of the motion. If you can move forward, backward, and they can move left and right. So this, if you change the normal or common wheels with this type of the wheels, we can achieve this omnidirectional motion. So, for example, if this type of the design people have done that they have this chassis and then they so this is the chassis over here. So, then they attach these four wheels on the diagonal So, if they attach in this configuration of these roller wheels, special roller wheels, so how they can achieve move forward, backward, left, right, and any direction. So, let's see. So, in this case, every wheel has one motor attached to it, of course, because we have to move this wheel. Let's say we call it M1, M2, M3, M4. So, if these are wheels are M1, M2, M3, M4 are rotate are I mean these motors are rotating forward in forward direction. M1 is equal to M2, M3 is equal to M4. So, they are all equal at equal speed. So, then this robot will move forward, right. And similarly, if we change the direction of the motors like minus M1, minus M2, minus M3, minus M4, so this robot will move backward. So, this is the simplest forward to achieve the forward and backward motion. So, how we get the move leftwards? So, the robot is standing here, just we can move it in this direction, right? How we can do it? So, in this case, we have to change the direction of M1 and M3. Which is M1 M3. So, here we have the M1 motor, here we have the M3 motor. We change the direction minus M1 minus M2, minus M1 minus M3, but M2 and M4 will remain same in forward direction. If we apply the signal or torques to our motors in this way, we move M1 M3 in the opposite direction and M2 and M4 in the forward direction, then the robot will move in the leftwards. Similarly, if we want to move in the rightwards, of course we have to change the. So, if we want to move the robot in this direction, for example, in this direction, what we have to do? We have to change the. It is simple to see that we can change. We will keep M1, M3 in same direction, but we change the direction of M2 and M4. So, then robot will move rightwards. So, this is simple like controlling the motion of our omnidirectional robot. Similarly, if we want to achieve this motion that robot spins on place, but like spins on the clockwise direction. So, how we can do it? So, in this case, the we change the direction of the motor. So, we change the M1 will remain same, but we change the direction of M3. Similarly, M4 will be same. We change the direction of it is like this. So, in this case, we achieve the we can achieve the clockwise rotation or anti-clockwise rotation depending on the changing the direction of the diagonal motors. And similarly, we can move this robot in a diagonal direction. Let me complete this one. We can move this robot in this direction or backward direction or in this direction or in this direction simply by this. So, if you want to, for example, move this robot in diagonal leftwards in this direction, so what we do? We stop M1, M3 motors. You know, this is M1, this is M3. So, we stop it and only move M2 and M4 in the forward direction. So, if we do like this, our robot will move in a diagonal direction leftwards. So, if we want to move in this direction, for example, right, we want to move our robot in this direction. Okay, so you can well recognize what we have to do. So, we will stop this motor M2 equal to 0, M4 equal to 0, and just move M3 plus and M1 plus. So, this in this, if we do like this, our robot will move in this direction. Similarly, we can move in left in this direction, in this direction. So, you see that by changing the this wheel configuration and changing the type of the wheel, we can build this omnidirectional robot, right. So, this is one type of the in our lab we do not have this type of the wheels, but in market it is available. So, if you are interested, you can build your final project based on this omnidirectional wheel configuration. So, this type of the robots are very helpful in on the flat surfaces, like in the factory automation, in Amazon, like warehouses, bigger warehouses like Amazon warehouses. So, we can put we can place a manipulator on top of it, then we can achieve any kind of the motion, left, right, forward, backward, diagonal, any type of motion. The other type of the omnidirectional robot is use another type of the specially designed wheels, which are called the mechanism wheels. So, these mechanism wheels, we put the rollers on the wheel on the diagonal, let us say 45 angle on top of the wheel. So, they can roll. So, these wheels can rotate or roll about their own axis like this. They can rotate, roll over this surface, this axis, and then and your overall wheel can move forward backward. So, this is the special design of the wheel, which is called the mechanism wheel, or also it is called the Swedish wheel. So, let me complete this. So, if we have the mechanism wheels, we can put them on our mobile chassis like this, if like in 4-wheel configuration, and then again uh, we can achieve by controlling the motion of these four motors, we can achieve omnidirectional motion. Let us see how we can do it. For example, again we have these 4 wheels, but now the wheels are not roller, but these are the mechanism wheels, and we attach them as in this configuration M1, M2, M3, M4. So, we can achieve the same forward direction, forward motion, backward, diagonal, or at leftwards, rightwards, by controlling the motion of these 4 motors. So, if we want to move these motors in the forward direction, we move all these 4 motors in a positive direction and forward direction, and then robot will move forward. And we want to achieve the backward motion, we will turn the sign of the motors minus 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 minus. So, then robot will move backwards. So, there is a simple forward backward motion we can achieve just by changing the direction of rotation of your motor. If you want to move your robot on left side, so what you do, you will keep M1, M3 in the forward direction and change the direction of your M2 minus or M4 minus. So, this way, if you apply the negative voltage to your motor 2, motor 4, and positive voltage to motor 1, motor 3, your boat will move rightwards. Similarly, if you want to move it leftwards, you will change the polarity of your voltage. If you want to move it leftwards, okay. So, what you do? So, it is simple to, you can see from this this configuration, you just change you will change the direction of M1 and M3, okay, and M2 M4 will move forward. If you do like this, your robot will move overall chassis will move leftward. Similarly, if you spin clockwise anti-clockwise, you can change the direction of in this case you change the direction of M1 and M4, and M2 will be plus, M3 will be plus. So if you do apply this voltage to rightwards motors as positive, leftwards motors as negative, your robot will turn counterclockwise. Similarly, if you want to achieve this clockwise rotation, you change the polarity, you make it this plus plus, and M2 and M4 M2 M4 will be minus minus. So this is very convenient again to change the polarity of your motors voltage to your motors applied voltage, and then you can achieve leftward motion, rightward motion, counterclockwise turn in place, right, clockwise turn in place motion. Similarly, you can move in the diagonal direction, in this direction, in this direction, in this direction, in this direction, simply by controlling the motion of the applying the voltage to it. So, for example, if you want to move in this upper right diagonal direction, what you do, you will stop M2 will be 0 and M4 will be 0, right. So, this motor will become 0, only this M3, M1, M3 will move forward. So, your robot will overall your mobile robot chassis will move at a 45 angle in upper right diagonal direction. So, similarly, you can move it in any direction. So, it means that by changing the speed, changing the direction of your voltage, you can move your robots in diagonal direction as well. Similarly, if you okay, here we see that M1 is equal to M3, but if M1 is not equal to M3, it's a little different speeds of M3, M1, M3. So, it will not move at 45 angle, but it depending on if M1 is greater than M3, it will move in this direction, right. If M3 is more than M1, it will move in this direction, right. So, it means that by controlling the speed and direction of your 4 motors, you can achieve any motion in the on the 2D surface, right. So, you see that this is very good design for the the application where the surface is rugged and surface is flat, like in the factory floor, or maybe in the hotels, in restaurants, in warehouses, in residential houses. So, this kind of robots are very convenient. So, I will stop here today because next we will develop some mathematical models for our mobile robot, and we'll see you in the class next Monday.